What's going on, Thomas?
Hey guys, this is Thomas Panner and Perry Kay. We're here to hang out with you tonight, and we are going to be talking about the philosophy of science, episode 2. So, what did we cover on the first episode? Well, we basically went over, let's see, we'll go to my notes here. We went over things like what the philosophy of science is. It questions the foundations, methods, and implications of science. We did an introduction to defining science, the demarcation problem. We can talk a bit more about that. But this is going to be the first in probably, I don't know, 5 or 6 episodes on the philosophy of science so that we can get all of the terms down and understand it really well before we actually go into the sciences. And we will be doing that. We'll talk about an outline of science, the scientific methodology. But right now, we're questioning the meta stuff, which is, can we trust scientific methodology? It's the scientific methodology of the scientific methodology, if you want to think about it that way. We covered Thomas Kuhn's 1962 book, The Structure of Scientific Revolutions, and how he saw things as like a paradigm to a set of questions or concepts within a particular historical period, randomly depending on the scientific discipline. So he looks at it in different ways. Um, so tonight we're gonna continue with what is scientific explanation, which is scientific inquiry, modes or models of scientific inquiry. Now, let's talk a bit just about the demarcation problem because me and Perry didn't get to go too deep. I think me and Don tangented off this. So, Perry, do you think things like psychoanalysis, creation science, and I don't know, pick your poison, astrology, should even be considered for scientific investigation?
Right. The only thing that I think that we should consider from it is its origins, right? Um, it was because of those things that, we're here where we are right now. I don't know if it was better that that happened. Perhaps there was a better way that normatively we could have started, but it is what it is in that case.
Yeah.
Nowadays, based on all of the things that we have, the pragmatic usage of all of these things today in 2023,
Mm.
probably not, unless perhaps you take it in the psychological domain, where you find as though I read my astrological zodiac signs or whatever every day, and I get some kind
Yeah.
of well being out of it. Other than that, no, I don't think that it is worth to consider, except for its origins. Um, but yeah, it's good to know about them, I'd say.
Okay. Yeah, I can agree to that. I think anything that doesn't follow the scientific methodology, especially the end part where you have peer review and independent verification, if somebody can't do the exact same experiment as you and come up with the same answers, and it be put forward to the scientific community for academic rigor's sake, I just can't trust it. Even Richard Feynman called it cargo cult science. For researchers believe that they are doing science because their activities have the outward appearance of it, but actually lack the what he called kind of utter honesty within science that results there that allows results to be rigorously evaluated. So basically, what I was just covering. The reason why the demarcation problem is so important in the philosophy of science is because, and even Karl Popper said this, and he's one of the kings of the philosophy of science. It's the central question in the philosophy of science because what is deemed as science is like kind of how you have it's a foundation. What you actually deem as science, what you actually deem as evidence. Ought we trust evidence? Ought we trust our senses? All of this is tied into the philosophy of science. So it's a bit normative. This is the normative part of science. Well, technically, this is the meta science, and then science itself would be the normative models that give us prescriptive analysis of a descriptive universe. Would you agree with that, Barry?
Yeah, reminds me of when we had Kane on the first time.
Yeah.
And I still consider myself a novice, but especially back then, and trying to differentiate, as you mentioned, prescriptive versus descriptive. It's like But don't we just prescribe even our descriptions, right? Um,
You're a little quiet, bud. I'm sorry.
oh, sorry. I mean, even our descriptive claims, right? Don't we prescribe them in such a way? Still having trouble hearing me?
I'm missing. I'm sorry, guys. We're having a little bit of technical issues. I can't hear the last parts of what you're saying. I got the first part, but not the
Hmm.
last part.
Well, it seems as though we prescribe even our descriptive claims, is what
Yeah,
I was
I
saying.
mean,
Yeah.
so a descriptive thing is what is happening in nature, because in science we're assuming the objective, right? It's a presupposition. So the descriptive is happening in nature, and then our models, our theories, are what is prescriptively described. Well, I mean, it is a description. You know what I mean? Like water finding its level or the speed of light. That's a description that directly correlates with math. Light in a vacuum, the speed of light is 186,000 miles a second or something like that. Um, that's a descriptive fact about photons and light in the electromagnetic spectrum. But the way that the mathematics that we've created to measure all of that is technically prescriptive because we made up the rules of mathematics. Now it's an open source deductive ideology, and whereas like science is an inductive open source ideology. uh, so I see a little bit of I see a little bit of differentiation there.
Yep, makes sense. We kind of prescribe the way our models, right? And that's what we're going
Yeah,
to get into.
so the laws are what is descriptively happening out there, and then the models are what are describing or what are attempting to relatively describe. Because I mean, like with math, with with mathematics, you can't exactly one to one reality. Like the speed of light might not be 186,000 miles per second in a vacuum. It might be 188,000 miles per second in a vacuum, and we're just the measurement issue is a problem
I
or something
always,
like that.
I always found that I always took that with a great, not always, but I've taken that with a great deal of skepticism.
Yeah.
186,000 perfectly. It's not
I
186
yeah,
and
I mean
524
maybe it
miles
falls
per
like
second.
that. Yeah, exactly. Exactly.
So
I,
that's
I
weird
don't
to
know.
me.
I don't know. I mean, it would seem like it would be like point non-repeating, non-terminating decimal sequence.
Either
Something
that
like that.
or we base our idea of the mile based on the speed of light. Like we take the speed of light, and that's
Mhm.
why it's such an even number. But I mean, what is it in kilometers? Kilometers, speed of light.
Uh,
It's another very. It's 300,000 perfectly.
yeah.
Like it's not 300,072 kilometers per second. Like I don't know. I find
Yeah,
that
I mean
very
that's a bit
interesting.
crazy. It's probably rounded off, I would imagine. They probably do that because it is in a vacuum and maybe it had, you know, I, the,
That's true.
the
Yeah.
speed of light doesn't know the base 10 mathematical system that we use to measure these things, right?
Yeah.
The
Um,
reason why
that
math
makes
works so
sense.
well is that it is deductive from its axioms. If you accept the axioms as true, it's deductive. That's why it can describe reality because it is going from the general to the specific. So that's why with math, it's closer to getting towards that one to one, but it's still not going to be the one to one, right? We can't. There is no mathematical symbol for infinity. We can't measure the wave function exactly. I mean, we're going to have to redo math multiple times in the next 100 years, or the next 200 years, I would say. But I don't want to get into the pessimistic meta induction. Let's not go down that
Well, I
road.
wouldn't even be pessimist. I'm glad that that's the case where we still have work ahead of us.
Yeah,
I'm glad
yeah,
that we don't have the end all be all. Personally,
yeah. Well, let's talk about scientific explanation. So this is the models of scientific inquiry. So after the demarcation problem, a closely related question is what counts as a good scientific explanation. In addition to providing predictions about future events, Society often takes scientific theories to provide explanations for events that occur regularly or have already occurred. So, it's in addition to providing predictions about future events. Well, that's what science is going for. And it says society often takes scientific theories to provide explanations for events that occur regularly or have already occurred. Yeah, that's probability on that last part. So, philosophers have investigated the criteria by which a scientific theory can be said to have successfully explained a phenomenon, as well as what it means to say a scientific theory has explanatory power. So, let's look at explanatory power. It's the ability of a hypothesis or theory to explain the subject matter efficiently and saliently. So it's the opposite of explanatory impotence, which would be the inability to uh, effectively measure what it's pertaining to, the salience of what it's attempting to measure. That's a big thing with scientific explanation. One early and influential account of scientific explanation is the deductive nomological model. This also goes along with the metaphysical question of nomological determinism, which means the laws of physics dictate everything all the way back to the Big Bang, and there is no will as of sorts. It's just a nomological, deterministic, causal, deterministic system. It says that a successful scientific explanation must deduce the occurrence of the phenomena in question from a scientific law. Now, remember, the law is the description of what's happening out there. It's actually what's going on. It's the thing that is uniform about physics out there. That's scientific laws. This view has been subjected to substantial criticism, resulting in several widely acknowledged counterexamples to the theory. It is especially challenging to characterize what is meant by by scientific explanation when the thing to be explained cannot be deduced from any law because it is a matter of chance or otherwise cannot be perfectly predicted from what is known. So let's try to understand that sentence again. It is especially challenging to characterize what is meant by a scientific explanation when the thing to be explained cannot be deduced from any law, scientific law, because it is a matter of chance or it can't be perfectly predicted from what is known. So, what do you think about what are the implications of that sentence, Perry? Do you have any ideas?
Well, I am having some trouble figuring out exactly what they're referring to when they're talking about chance.
Yeah,
Um,
that was a question of mine as well, and this is from Wikipedia. I'm reading the scientific explanation off Wikipedia, but when we go to justifying science, we'll be going to Stanford Encyclopedia. I just found better ways to explain the explanation part, the models of scientific inquiry through Wikipedia than I do through, and I'm paying attention to see if the sources are good. And I've checked 4 or 5 on this page, and they're very reliable, so we can trust this page, okay?
right.
But yeah, we can trust it as much
So
as we can trust the Stanford Encyclopedia.
when we
Go ahead.
go into a scientific inquiry, are there always is there always going to be a scientific law that we can refer to, um, or are there certain things where we
Well,
just won't
shit's
have
going
something
on out there in a uniform way. Would you agree?
in a uniform? Ooh, uh, is uniform juxtaposed to chaos? Because I think that there are some chaotic elements of nature.
What in nature do you think is chaotic?
Combustion.
If
Okay.
you knew every placement of every explosive event within that event itself, within that system, then you could physically Laplace's demon it.
Laplace's demon, right?
Yeah.
Um, if right, unless we lived in a universe of indeterminacy, perhaps.
Okay. If it's indeterminate, then the very nature means that that randomness can exist in some way that we can. To me, the only way I can understand randomness is that it's an order that we can't comprehend yet, or measure, or notice.
Fair enough. Yep. Well,
So it may as well be random to us, but I would not call it in the ultimate sense random.
Yeah, and I suppose you can do that with any hypothetical that I come up with, and fair enough. I would agree, right? That things are uniform as so far as if we understand it, if that's what you mean by uniform, if only we were Laplace's demon, right?
Well, we
Um,
understand it, right, to a certain degree, but what is going on if we're looking at this through a scientific lens, what is going on in objective reality in the noumena, if that's what you want to call it, is what's the best way to say this? It's um it's happening, right? I'm trying to get back on track. What was I saying? Oh
well, we're
my
talking
god.
about we're again the semantic usage of uniform, and
Yeah.
if the universe is uniform.
Okay, let's go with the term then. Uniformitarianism assumes that physics has been uniform to the point of, you know, matter, mass is always going to fall towards the Earth at 9.8 meters per second squared.
Mm-hmm.
It's been that way since the formulation of the Earth and the rotation and the spin on its axis. Would you agree?
Yep. The only counter to that I've tried to think of in the past is if our physics was localized, and if we go, a million light
Yeah,
years this
if
way,
it's
it's different.
plurality and there's a different substance and there's a different physics to that substance, I'm open to that idea.
Which again, that would be uniform. I'm assuming would be your response in some way that we're just not
Yeah,
aware of,
it would be
right?
Spinoza's argument that all the different plural forms would be uniform in themselves, forming a tapestry.
So, so to answer your original question, yeah, tentatively, I'd probably say, yeah, the universe is uniform based on our understanding and our not missing, but our unknowing of certain things as well. We could probably assume safely that what we don't know is also uniform. Um,
It would make sense that, I mean, just because of the natural argumentation, logical argumentation here, that order would only be. It's the kind of same thing as saying nature is all there is, but you have to have a relative comparison term, at least in linguistics, to say non-nature, right? Non-natural. But what is non-natural? It's the same thing as asking, well, what is random? It would just seem to be an order. Who could sit out for 1 billion years and calculate pi out to a certain degree to where if you backed out on it far enough, you would see a pattern, right?
or you figure out that there is a final number, right?
Yeah,
And
there
that's
might be a final number. Exactly. It might round out to be some kind of 9 trillion decimal places later. You've got the right number.
my guess is 7. The last digit is
I
7.
hope so. That's my favorite number. I fucking hope so.
Um, but yeah, what is non-natural? That which doesn't exist, as far as I'm concerned.
Yeah, and that's the
So
and that is the contrast that you have to have in order to understand what is natural, right? It's kind of like the something and nothing paradox. Well, there always has been something, and there never was a nothing. I mean, that is just sound logical argumentation to me. It doesn't absolutely prove that that's true. I've never had a nothing to experiment on. I don't think the moment you give nothing properties, it's something. So we won't even get into ex nihilo. But
sure.
um, Wesley Salmon developed a model in which a good scientific explanation must be statistically relevant to the outcome to be explained. Well, duh. The salience argument, right? Others have argued that the key to a good explanation is unifying different phenomena or providing a causal mechanism. And that's another duh, right? We want to know causal mechanisms. So this is all fitting within the models of scientific inquiry. There are obviously like a classical model, um, and a couple of these sections are need more expansion, but they do have sources. So the classical model of scientific inquiry derives from Aristotle, right, who distinguished the forms of approximate and exact reasoning, set out the threshold scheme of abductive, deductive, and inductive inference. That's actually incorrect. Abductive was formed in like the 1800s, so that is not. Can you look up real quick who came up with abductive reasoning?
Yep.
I can't remember the name. Um, So, but that would be the classical model, is like Aristotelian classical logic. But so let's explain this real quick while Perry's doing that.
Yeah,
What we were talking about a
you're
second
right.
ago.
By the way, it's
What's that?
by Charles Sanders Peirce in
Yep, I
1865.
fucking knew it. So they got that
Yeah.
wrong. Deductive and inductive logic actually existed back in the time of the pre-Socratics. So the problem with the way to look, this is a meta epistemological problem. And the problem that Sextus Empiricus, a Pyrrhonistic skeptic, Sextus Empiricus, what he brought forward was the problem of the criterion as it was understood by the Greeks at that time. There is another way to understand the problem of the criterion, but I've gone over it in other episodes and we may cover it later. But Sextus Empiricus basically said you have inductive, which is observation, and you have deductive reasoning, which is the premises naturally follow to the conclusion if it's valid and sound. Well, criterion is something that you have to use in order to prove something else. It's like an axiom. It's a little different than an axiom, but just flow with it. So if you're inductively looking at something, you're relying on past experience. Well, the criterion for past experience is just more past experience because that chain never ends. You can just keep going back and saying, well, what's the past experience of that? So there's an infinite criterion backwards that forms an infinite chain, and that can't happen. So there's really no criterion for inductive reasoning, which is the basis of science, the basis of the beginning of the scientific methodology. So Sextus Empiricus also said that with deductive logic, you are making the rules and saying, well, valid and sound premises lead to a natural conclusion. That's logical reasoning. The problem is you're using that deductive argument as the criterion itself. And you can't do that because that means it's arbitrary and circular. Well, the criterion is the argument. The argument's the criterion. The criterion's the argument. The argument's the criterion. So there is no actual knowledge. That was what the Pyrrhonistic skeptic, at least Sextus Empiricus, came to, and that is a big part of today. Even the classical model of scientific inquiry, even though they weren't thinking scientifically back then, but they did at least come up with these amazing thought examples. You have anything to add
Well,
before I keep going?
why is it? And I get that issue. Why is it that we can't have knowledge though, just because it's based on our like a meta past experience thing?
Because the criterion would be what would ground it, the justification, and since it's the same thing as the Agrippin trilemma, you know what I mean, or the whatever you want to call it, the Munchausen trilemma. It's the theories and problems with justification, infinitism, uh, circular, or foundational in terms of the theories of justification. So it kind of works the same way. That problem comes up everywhere in meta epistemology, normative epistemology, and applied epistemology. The problem of the criterion, because you have to have axioms for your systems if you're going to have a system. And if you have an inductive system, that criterion goes back forever. If you have a deductive system, itself becomes the criterion. So I guess you don't necessarily. I mean, you could just accept things on faith or on a guess or on intuition, but the criterion has to be something which is logically reasoned as a foundation before an axiom. I don't know how to explain it easier than that. That it's foundational
Yep, that makes
to
sense.
any system of logic.
Makes sense.
Yeah, yeah, and I mean, you may be right. Um, Logical empiricism. We've already talked about logical positivists. That's a model of scientific inquiry. Let's see. Choice of a theory. During the course of history, one theory has succeeded another, and some have suggested further work, while others have seemed content just to explain the phenomena itself. The reasons why one theory has replaced another are not always obvious or simple. Duh. The philosophy of science includes the question, what criteria are satisfied by a good theory? This question has a long history, and many scientists as well as philosophers have considered it. A lot of these duh sentences. The object is to be able to choose one theory as preferable to another without introducing confirmation bias. Several often proposed criteria were summarized by Kolyvan. A good theory is, number one, contains as few arbitrary elements as possible. Um, Number two, agrees with and explains all coexisting observations and makes detailed predictions about future observations that can falsify the theory if they are not borne out of that observation. So, agrees with and explains all existing observations through explanatory power, like we talked about earlier. So if something can't fit in with the model that's already there, it agrees with and explains all existing observations. Of course, we can't do this in a scientific methodology. You can't know all existing observations. You can only have a set of specific observations and then generalize from that. So I don't 100% agree here, but we'll move on. Uh, Number three is fruitful, where the emphasis by this is a scientist. I don't know his first name. It just says Kohlevin. So emphasis by Kohlevin is not only upon prediction and falsification, but also upon a theory's seminality in suggesting future work. How well it continues to function as time goes on. So that's agreeable. And number four is elegantly formal, which means that it's rigorous, academic, peer reviewed, independently verified, yada, 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 yada. Stephen Hawking supported items 1, 2, and 4, but did not mention fruitfulness. On the other hand, Thomas Kuhn emphasizes the importance of seminality because of his ideas of different parts and different cultures, paradigms, and that we should look at science that way. Uh, he cares more about how long a science lasts and how, like evolution or physics. The shits, it may have thrown out some old and come in with the new, but I mean it's still physics. You know what I mean? Still discretizes existence for us.
Yeah, I was thinking of Kuhn as well when you were talking about, using past observations and whatnot.
Mm-hmm.
That's what he would call normal science.
Yeah,
And if we ended up finding some anomalies or contradictions and whatnot, we would need a revolution of some sort and to create a new system with new axioms, etc.
exactly.
Um, but yeah, sounds good. I mean,
Yeah.
actually, can you talk about that fruitful part again?
Yeah, I don't know about that. Kolovin says number three is fruitful, where the emphasis is not only upon prediction and falsification, but also upon a theory's seminality in suggesting for future work. Seminality just means like seminal, how well it works over time, how strong its roots are, right?
Okay,
Like if something is seminal when it is appreciated later at past the date of which it was formed.
gotcha.
That can be with an album in music, right? You can have a seminal album
Or
in music.
yeah, Marcus Aurelius's Meditations,
Yes,
where
Meditations is
right,
extremely seminal.
yeah,
Yes. So I don't know why he said is fruitful, but this is Colvin's idea, So the goal here is to make the choice between theories less arbitrary. That is a problem in science, especially with coming up with a test. That's about as arbitrary as it gets. When you're studying to come up with a test, all you have is previous tests within the models that are already there. What if you come up with something completely new and you have to use models that are already there that don't comport with what you're finding? You know what I mean?
would you say that modus ponens is arbitrary?
If we agree that if P then Q, P therefore Q, that is deductive from the valid and sound premise. I mean, it's sound because we're using atomic sentences. We're using atomic variables, P and Q,
Hmm.
right? We don't have to argue about whether P is P or Q is Q. If you want to, we can.
Gotcha.
But so yeah, there is no normativity in the modus ponens. The 9 rules of inference, those are all like deductive syllogism and all that kind of stuff. Disjunctive syllogism, all that shit. Modus ponens, modus tollens. Those are the 9 conditionally in the square of opposition with from Aristotle. Those are the 9 conditional forms of of log. Those are the 9 conditional logical forms. Uh, so there's 250 in logic. There's 256 forms in the square of opposition that Aristotle created. Um, and there are 24 that are valid, and there are 15 that are unconditionally valid, and then there are 9 that are conditionally valid, and those 9 usually directly map with the models of inference. I can actually pull up the 9 models of inference, or the rules of inference. I'm sorry, but
So Randy says, hasn't David Deutsch fleshed all of this out? I don't know if you've heard of David Deutsch at all. I've heard of him through certain talks and whatnot, but I don't know any of his work.
I'm not familiar with his work. And you know what? He may have an amazing, well formed theory of all this, and
Yep,
I'd love to learn it. But we're going to learn from all sources that we can. We're not just going to learn from one person. We're going to learn from as many different ideas as we can from this, so that we can completely understand the philosophy of science. I mean, I'm down for you, in chat, or if you want to join our Discord and give some of that information. I would absolutely love to hear it.
yeah, you should
Absolutely.
call in Randy, or maybe if you want, briefly put it in the comment section.
Yeah, we
But
can copy it and maybe put it on Discord in our server and see what people have to think about it, and see what they have to pick it apart or to agree with it. Things like that.
yep, I'm gonna throw a call in link in the chat.
Yep.
Feel free to
So when you come
call
into
in, guys.
the so we're still covering our information right now,
Ah,
guys.
yeah, good call. True.
Yeah, we're still. I'm just letting everybody know this. We're still covering our information right now, guys, but we will have callers at the end when I'm done covering what I want to cover here, and because I'm learning, and I'm also attempting to share this understanding through the dialectic with me and Perry, so that because that's the way a lot of people learn, and I think that's very important. If it's cool, there's plenty of people who I think might have everything fleshed out. All these popular theoretical physicists, Sean Carroll, Lawrence Krauss, Brian Greene, Brian Cox, all these people may have it completely fleshed out at some point in their own way, and we will be looking at those characteristics when we get to physics. Those characteristics of those people when we get to physics. I don't even know if I said that right. That sounds like a bad sentence now. God.
Randy, I couldn't post in the chat the Discord, but here it is. Uh, I'll leave that up there for a little bit for you to join, and everyone who's watching, consider joining the Discord. We talk a lot about philosophy, politics, religion, uh,
Mm-hmm.
everything. So,
Yep.
okay, Travis put it in there. Good. All right.
Excellent. Thank you. Thank you. So we understand about scientific explanation, what makes a good explanation, what is explanatory power when it's salient, when it pertains to what you're trying to predict, it's salient and it fits with other models.
Oops.
That would be my argument. But there's all there, explanatory power is scientific realism and anti-realism, which we will cover, is fucks with this in a way. You know what I mean? Where it doesn't make it so cut and dry as to whether we've successfully explained a phenomena. To be honest with you, and maybe Perry agrees, I don't think we see, even with mathematics, I don't think we see reality, the scientific laws, the descriptions of things that are going on out there that are actually uniform. I don't think we see that anywhere near one to one, anywhere near it, because evolution has instantiated us in such a way that we see things that are useful to us and pragmatically allow our survival and our thriving. What would you think about that, sir?
Yeah, yeah. One of Travis's quotes is, "Aren't we all just straw manning reality?" I
Yeah.
mean, it's true. We don't see reality as it is. We're giving an improper argument, and we're not steel manning it properly. If only we were to steel man it perfectly, then
Well, our senses can't steelman it properly. I think it's. I don't know if it's a fault of intellect, maybe a fault of the senses, right?
yeah. And sure. I guess all I would say to that is, and I've been thinking about this a lot lately. and doubling down on it. I can't think of a way where we can know anything without our senses. Yeah, our senses are fallible, but how do we know anything without those fallible senses?
I don't know. The floating man argument's just a bunch of nonsense if you don't take it as a thought experiment.
So, so are you attempting to say that our intellect and rationality is more finely tuned and less fallible than our senses? Would that be an argument that you would make?
No, I mean, there seems to be some intuition to our rationality, our rationalism. Um, that, but I mean, there's also some intuition to our phenomenal sensory experience as well. So I think it kind of plays in both fields. I'm not sure. I don't know. It's a hard question. What do you think?
I've never considered it until I just said until we just brought it up. I mean, I could see an argument being made that if we're going to dichotomize these two things, which could be a false dichotomy, but let's just take it for now that we have our intellect and we have our senses, right?
Sure.
Now you call
A priori and a posteriori for
you,
the audience there.
you say that a priori and a posteriori are two sides of the same coin, right?
Yeah, you got to have
Um,
your senses if you're going to make any mathematical deductions, right?
Right. So, in that case, I'm not sure if we could dichotomize it, but if we were to, I could potentially see an argument that our intellect or, our rationale, a priori, whatever you want to
Yeah,
call
yeah,
it,
yeah, yeah,
would be more sophisticated in a manner or less fallible than our senses. I could see that. I mean, Plato
yeah,
thought that for sure.
yeah.
So, so yeah, I could definitely see an argument being made for that. I don't know though. I think it's a false dichotomy from the
No, it
outset.
might be a
But
false dichotomy. I mean, it seems as though everybody in epistemology wants to make that dichotomy in the past, at least, between senses and mind dependence. But
yeah,
we're playing in the realm of science right now, and we have to assume physicalism. We have to assume an objective reality that we can use science and mathematics to predict. That's why we have technology. That's why we can do what we're doing right now. Um, so its practical application is beyond example.
that's what I
It's
was
the
going to say.
most
Yep,
evidence you could want.
it's
Mhm.
pragmatic. So it's
Yeah, I
pragmatic
mean, there's tons of
dichotomizing.
evidence for why the scientific method works. iPhones, right? Um, tons, millions of examples as to why. I mean, dump trucks. Just name one thing, and science has given us these things. So let's see. Let's talk about the problem of induction because this is going to come up. And Perry, I know you know a lot about this, so I'm gonna let you explain it if you want to.
What is it? I'm sorry, I was reading a
The
comment.
the problem of induction.
Oh, sure. To put it briefly, it's the future. We can't expect the future to be the same as our past, right? We can't just because we have these past experiences and past observations doesn't necessarily follow that the future will be the same, right? The I love saying this. This is why I'm not 100% certain on anything, right? Um, I don't know 100% that the ground below my chair won't just cave in and fall, right? But I'm 99.99999% sure that it probably won't based on my past experience. But there are many cases where the future doesn't necessarily represent the past. Hence,
Mm,
paradigm shifts that Kuhn
yeah,
gave us.
and why this is so important, and I know you'll agree with me, is that science is induction. We make specific observations and we attempt to generalize from those specific observations. Deductive is taking the general and specifying it to one problem.
That's why a good scientist will never tell you that there are absolute truths in science. No
Yes,
good scientist will say that for that reason. Exactly.
yes. So let's see here. Okay, so although it is often taken for granted, it is not clear how one can infer the validity of a general statement from a number of specific instances, or infer the truth of a theory from a series of successful tests. Basically, what you were just saying. One approach is to acknowledge that induction cannot achieve certainty, but observing more instances of a general statement can at least make the general statement more probable because we had prior occurrences. Probability requires prior occurrences, a numerator and a denominator, so that you can get a graph. Um, for example, a chicken observes each morning that the farmer comes and gives it food for hundreds of days in a row. The chicken may therefore use inductive reasoning, if it could, to infer that the farmer will bring it food every morning from then on. However, one morning the farmer comes and kills it. How is the scientific reasoning itself more trustworthy than the chicken's inductive reasoning? And it said, so the chicken would be right to conclude from all those mornings that it is likely the farmer will come with food again the next morning, even if it cannot be certain. Of course, here we are fallibilists. We don't deal with the realm of the absolute or the Cartesian certainty. However, there remains difficult questions about the process of interpreting any given evidence into a probability that the general statement is true. And that's, of course, what we care about if the general statement of science is what gets us closer to the truth, that which comports with reality in a physicalist ontology. So, one way out of these particular difficulties is to declare that all beliefs about scientific theories are subjective. That would be a bit of scientific anti realism. They are mind dependent. Um, and the question of how evidence should change these subjective or mind dependent beliefs over time is another inquiry that we have to follow into. All these questions are extremely important, and to justify science, to say that we have this problem of induction, and the chicken can get killed even after it's been fed thousands of days in a row or whatever. Um, we have to use it. We don't look at something and observe something in science and say, oh, I can deductively prove this. I'm looking at something general and I can take it. That's not how you reason. You don't start with a general observation, just like looking at something generally and saying, how can I make a deductive argument out of that? That's backwards. You're looking at something specific and attempting to use general knowledge to, past knowledge, in order to focus in on specifically what you're attempting to get from the observation, to understand from the observation. I hope I explained that well. Sometimes I get rambling and I get lost in my rambles.
You did,
Um,
but I also know your lexicon very well, so it's,
yeah,
I understand. Uh,
thank-
you mind if I bring Nivik in real quick?
yeah. Go ahead.
Okay. And before you go, Nivik, Randy also asks, is consciousness a sense? Einstein used pure consciousness to do the deepest science with his own brain. Well, perhaps it's the overarching sense of our other 5 or 6 senses that we have. Um, I don't know if I'd call
I
it
would say
saying truth.
consciousness involves everything about our individual existence. I mean, consciousness pretty much sums up everything from intellect to feelings to attitudes to personality traits. I mean, it's all kind of under the umbrella of consciousness. So that's
Agreed.
the thing that we all intuitively feel, that intuition that I was talking about again, but we can't describe, or we can't delineate from, what it is in the brain that makes the mind. Um, so yeah, it's a ghost in the machine question, and consciousness. I mean, Einstein thought a number of many things about his theories, but what is best and most relevant from Einstein is the things that he gave mathematics that showed predictability. The reason why his formulas were so important is because they predicted in space time the same thing over and over and over and over. And yes, it's being changed now. It's slowly morphing into quantum gravity and quantum loop gravity and string theory and all this stuff. But it's important. Would you disagree?
Nope. Very well said.
Yeah.
We got the Nivekian unit on. What's up, Nivek?
Yeah. I
Hello,
can't hear. I can't hear
Nivek.
Nivet.
Me neither.
Hello.
Yo.
Hey,
Hello.
there you are, buddy. What's up?
Oh, how'd that happen? That's
I
Good
don't
crazy.
know.
luck.
Um. Oh, I can't leave the. Sorry about that. Hold on. Can you?
It's all right. You're breaking up a little bit though. You having difficulties, Perry?
Hello. Hello.
Hello, I'm here. Can you hear me, Nivik?
Oh, okay. No, I'm just having difficulty. Sorry about that.
It's all right. Is Perry there? I haven't even looked back on my screen. Okay, he's there.
You hear me? Yeah, yeah, I'm
Yeah, I
here.
can hear you now.
Yeah.
Okay.
Well, did
I
you have a
can't.
question, Nivik, or what's
Well,
up?
no,
What's
I
on your
just wanted
mind?
to. Uh, yeah, when you guys were talking about order,
Order and randomness.
yeah. Um.
Okay.
I, or order. Order is Sorry about that. The thing about it is, I had my question written down, and when I
It's okay.
leave from the app, when I leave from where I'm at, it drops me. It takes me out.
Okay. Well, take your time. It's not a big deal. We're not in a rush. We're
I was
sitting
trying
here
to.
learning.
I was trying to remember what I was trying to ask. Um, when you were talking about order and chaos,
Yeah.
um, it it's kind it's about the perspective, and where chaos and order, they're kind of it depends how you want to look at it. If you see something, you identify it for what it is, and that thing breaks down from what you from what it is. That's being in a state of chaos. Like if you build a snowman, you put it in warm water,
Mm.
it breaking down would be a state of chaos. And I get where you're coming from, where you're saying like with patterns, but I mean, I think it depends how you want to identify something, because pattern is in everything. But if you identify something wrong, where that if you that it sorry about that.
It's all right, Nick. I know. Go ahead.
If you misidentify something for what it is, then that's that's
Are you trying to tie this back to chaos?
yeah. Because you're saying like everything has a pattern, but if you if something if you misidentify something for that pattern, and that thing is and something's being broken down, it's not order at that point. It's
What breaks down that isn't ordered?
the complicate the complicating thing between order and chaos is that they're both the same thing. When something is being broken down, something's also being created. So it's kind of a perspective kind of thing. You know what I'm saying?
Well, I don't know if creation and destruction is the same as order and chaos. I would say those are two different things.
Well, I would I I'd say that they're not, because if you have um a norm and as a particular environment, it could sustain a certain order. If that environment changed, that whatever that norm that adapted that was able to adapt to that environment, it would break down, like the snowman in warm water. So that snowman will be in a state of chaos.
So entropy in any closed system randomizes what's happening inside the system. But if I don't know if it's truly random, because
Right.
in entropy, there is no closed system, by the way. So entropy is probably just when entropy breaks things down into thermal equilibrium, like the universe will go into a heat death. That's still not technically random, but it's that energy can't do work on matter. Everything is like lukewarm and thermally equilibrated. So that's my idea of if we could have a specific and meaningful way to tell people what chaos or what randomness is, then it wouldn't be so difficult to talk about, because mathematicians have this problem all the time. What is true randomness? Because what a mathematician means by random might not be what we're talking about, right? We don't know exactly the highest forms of what random can be, because that would take theoretical mathematics. That would take some things that we don't know about here. But I would just argue that logically, randomness can be something as a placeholder, like a word, and say that is random. But I don't know if we can ever show through a demonstration that something is completely random. That's my argument.
In chat, we have Winky Winky Woo. He says, or she, they say, if chaos displays a pattern, then I would argue it's not chaos. I
Yes.
think that sums it up pretty well. I mean, you probably could semantically find your way of
Okay.
making a counter to this,
Okay.
right?
So
But yeah, go ahead real quick, Nivik, and then let's get back on track, and then we can go into free for all. But go ahead and rebut.
okay. So if you had something that you identify, if you had something in a set pattern, that that had an identity, that thing that you broke down from that identity, from what you identify, it wouldn't that thing now be in a state of chaos?
Perry, you want to handle that one? I
Yeah,
don't know
yeah,
how
yeah,
to.
sure. So I think, Nivik, what it comes down to really is chaos and randomness, as so far as most scientists' presuppositions. Chaos and randomness are simply our non-understanding of the situation at hand. If only we were Laplace's demon, if only we knew more so about the essence of reality, of nature, then it wouldn't be random. It would be ordered. We would understand the patterns, or whatever word you want to put there. And once we understand it, it ceases to become. I mean, a lot of things are random, right? For the non scientific mind, a lot of things are random. It's like, oh, there was a ghost, right? When in reality, it wasn't a ghost. It was some other phenomenon that happens in nature. But I think, just to kind of tie this up, it is our
Can I explain myself a bit further?
Nivik, buddy,
we got
let
to get
let
Sorry,
back
Perry
on
sorry.
track.
finish, and then
I,
he'll
I, I
probably
think, yeah,
yeah.
I think we can get back to it a little bit later.
Okay.
Yeah, but I'm not sure if you heard what I said, but it is our not knowing of a situation that makes it random. I would say. Uh, let's uh, let's
Yeah.
consider maybe getting back to the next segment, and
The
then
next segment, yeah, we'll
yeah,
talk a little bit more. How long we've been going, Perry?
we are at about 53 minutes.
Okay, let's talk a little while longer, because I'm having fun with this, and I know this is enjoyable to you too. And I hope our audience is enjoying themselves, because that's why it's called torture time. We love to do this to ourselves. We love to understand something as well as we possibly can. We want the academic rigor that is necessary to understand some of we're not going to start like putting down equations and asking you to solve them, but we are going to get into every concept we possibly can.
Not
uh,
yet, at least.
yeah, not yet, at least. Maybe one day we'll be good enough to sit here and go through equations with you. But I don't think that's important to learn through the dialectic. We're learning about the philosophy of science
Yeah.
easily enough through the dialectic without even having to get to any actual show your work kind of implementation, I guess would be the best word to say. Um, so there's a couple more things I want to say about justifying science. And we can even say, justification and science are inherently tied together, because justification is what gets us closer to truth. And I argue that with justification, it needs to be some form of scientific methodology to get us closer to the truth. But the real problem is, what justifies an explanation in science as being the correct explanation? Well, you could say falsifiability, you could say independent verification, you could say put it through the open source test and see if you can do it at home or in a lab. So justification is intrinsically linked to scientific explanation in general. So it says some argue that what scientists do is not inductive reasoning at all, but rather abductive reasoning, like we just talked about Charles Sanders, Pierce, whatever his name is, or basically an inference to the best possible explanation, basically like a detective would do. In this account, science is not about generalizing specific instances, right? But rather about hypothesizing explanations for what is observed, following the evidence where it leads. As discussed in the previous section, it is not always clear what is meant by the best explanation, right? That's one of the prime examples we're giving here. Occam's razor, which says don't multiply entities needlessly, is basically, in the very simplest terms, saying that the more simple your answers are, the less you appeal to unknowns, the closer to the truth you are probably going to be. That's really what it's saying. That's why it says don't multiply entities unnecessarily. And it plays an important role in some versions of this approach in science. And I agree with that. You know, we get more simple and we get more elegant and efficient and clean, the better our understanding of nature is going to be, because it seems to be uniform, and that's what we're following. We say mechanical, like quantum mechanical, but I don't know if it can actually be called mechanics. I'm not, maybe. I have a problem with that in my mind, because at the quantum level, it's an ocean, and yes, hydrogen and oxygen in the ocean, hydrogen and oxygen in the ocean are doing their thing. I forget where the fuck I was going with that, so we're gonna move on.
Well, you'd rather use ocean or plenum. I've heard you say
Yeah,
instead
plenum
of
is a good word for
mechanics.
that. Yeah, completely full space. So, to return to the example of the chicken, would it be simpler to suppose that the farmer cares about it and will continue taking care of it indefinitely, or that the farmer is fattening it up for the slaughter? Philosophers have tried to make this heuristic principle more precise in terms of theoretical parsimony or other measures, which means succinctness, succinctness, really. Yet, although various measures of simplicity have been brought forward as potential candidates, it is generally accepted that there is no such thing as a theory-independent measure of simplicity. In other words, there appear to be as many different measures of simplicity as there are theories themselves. And the task of choosing between measures of simplicity appears to be every bit as problematic as the job of choosing between theories. Okay, Nicholas Maxwell has argued for some decades that unity, rather than simplicity, is the key non-empirical factor in influencing choice of theory in science. Persistent preference for unified theories, in effect, committing science to the acceptance of a metaphysical thesis concerning unity in nature. So, that's what we've been talking about. In order to improve this problematic thesis, it needs to be represented in the form of hierarchy of theses, each thesis becoming more insubstantial as one goes up the hierarchy. That's an interesting way to look at it, but I don't necessarily agree with how Maxwell has framed it. But I don't know. It's and these sentences are somewhat difficult to understand because they're long. And I get that, and it's hard to understand sometimes just for me. Some people on here are probably like, "Yep, I got it immediately." And with my ADHD ass, and my obsessiveness, I always have to read things multiple times. Well, not always, but sometimes have to read things multiple times in order to understand it. So the metaphysical, he was talking about he was basically talking about the metaphysical thesis concerning unity in nature, and that is a metaphysical question. Uniformitarianism is is nature uniform, right, since the Big Bang. So, before I move on to observation inseparable from theory, which is a very small segment, did you want to comment any further on um, the abductive reasoning, the Occam's razor, the succinctness and
Yeah,
parsimony?
Maxwell and whatnot.
Yeah,
Well, that kind of last bit where Maxwell was saying that there's somewhat of a hierarchy of certain theories that we
as
use.
a unity rather than simplicity in the key non-empirical factor in influencing choice of the theory and of theories in science.
Yeah. Um, I would. I don't see much wrong with that. In terms of Occam's razor, simplicity is better than, well, I don't know, complexity. Is that what we're
Well, it's
juxtaposing?
don't multiply entities unnecessarily. Don't appeal to unknowns to explain an unknown. Usually, the razor means that the more simple you attempt to make the explanation, the closer to the truth you're more likely going to be. Because if you use entities and extrapolate and extrapolate and extrapolate, the further you're going to get from an explanation that might be close to the truth because of its simplicity.
What if we have to extrapolate in the linguistic domain and have to kind of make it more difficult within the words that we use in order to have that one word or that one term to make it simple? Um,
Hmm.
Perhaps we don't have the proper terms and we have to kind of go down that complex road of semantics to make it simple in the scientific domain.
Yeah. And it does say, in other words, there appear to be as many different measures of simplicity as there are theories themselves.
Mm.
And the task of choosing between measures of simplicity appears to be every bit as problematic as the job between choosing between theories. So that is problematic. But simplicity is what we're looking for in science. We want the grand unified theory, which is having all of the forces unified in some way. I mean, that would be simple, that would be elegant, it would be succinct, it would be salient, and if it could make predictions better than what we have now, that would be amazing. Usually, that better predictions come with simplicities like general relativity and things like that are just specifically about one facet of gravity, and then special relativity that's about the facets of energy and matter being interchangeable, basically. So it says, okay, so let's real quick, let's talk about observation is inseparable from theory. Let's cover that real quick. When making observations, scientists look through telescopes, study images on electronic screens, record meter readings, and so on. Generally, on a basic level, they can agree on what they see, right? But if these scientists have different ideas about the theories that have been developed to explain these basic observations, they may disagree about what they are observing. For example, before Einstein's general theory of relativity, the general theory, observers would have likely interpreted an image of the Einstein cross as 5 different objects in space. So the Einstein's cross is a gravitationally lensed quasar that sits directly behind the center of. Okay, interesting. In light of that theory, however, astronomers will tell you that there are actually only 2 objects, one in the center and 4 different images of a second object around the sides. I assume that's through gravitational lensing. Alternatively, if other scientists suspect that something is wrong with the telescope and only one object is actually being observed, they are operating under yet another theory that may be false. Observations that cannot be separated from theoretical interpretation are said to be theory laden. Theory laden, which means in the philosophy of science, observations are said to be theory laden when they are affected by the theoretical presuppositions held by the investigator. So that's pretty obvious. If you're using your presuppositions, which you're going to, then it is theory laden. So how do you get away from theory ladenness? Any ideas, Barry?
No idea.
Me either. So how do we differentiate, since the explanation of Einstein's cross there, the astronomers say there's only 2 objects, but if you use general relativity, observers would have likely interpreted Einstein cross as 5 different objects in space. That's
So
interesting.
depending on the paradigm in which one utilizes, kind of seems like.
Yeah, and Einstein wasn't an astronomer, so I think they're jumping sciences here. But he still technically would have been incorrect by scientific standards, right?
Right.
Or if
Yeah.
somebody
Right.
he wouldn't have been incorrect, he would have known this, but someone who was doing work with his theories.
Whatever paradigm or standard in which you use will determine whether it's true or false, right? And of course,
Yeah, I mean that
depending on its.
you're talking about constructivism, constructive empiricism, right?
Yeah.
Yeah.
Yep.
So alternatively, if other scientists, okay, I already said that. So something is theory. Let's go over this one more time. Something is theory laden when a theory is affected by by the presuppositions held by the investigator. Okay. So Thomas Kuhn was a big part of theory ladenness. That's important to remember, but it's one of those not so important things to remember. It's just you need to keep it under consideration. All observation involves both perception and cognition, or a priori and a posteriori. That's what it's saying. Um, that is, one does not make an observation passively, but rather is actively engaged in distinguishing the phenomena being observed from the surrounding area or sensory data around it. So we can say this right here just kind of goes along with what me and Perry are saying. You can't have cognitive rationalism without your phenomenological perception or your sensory network. You have to have the empirical before you can get the rational, or both, however you want to do. You're doing both at the same time. You can't separate them. Um, I don't think anyway. I could be wrong, but I don't think so. Um, so it says one does not make an observation. This goes to the observer effect in science, which is the fact that you're observing. Your observation is the very observation that you are doing is changing the experiment, and that is true. It's different from the Heisenberg uncertainty principle in quantum mechanics, but the observer problem, the observer effect, is something serious in science, and it's another part of the philosophy of science. So
Well, in regards to the observer effect and whether one comes first or the other, rationality versus empiricism,
mhm.
what if I made the argument that when I'm looking at my screen right now, there's a little bit of lag time, right? It takes zero
Yeah.
point zero 0.03 seconds, milliseconds, whatever it is, before it goes through my optic nerve and then actually does the firing in my brain. So couldn't I say potentially that it's the empiricism that comes first and then the rationality, just simply based on that lag time?
Maybe within the light speed transmissions of our brain, perhaps. Yeah.
Sure.
I mean,
And that, yeah, yeah.
can they both act simultaneously?
I can definitely see a world where they both happen simultaneously. I've thought about that, many times.
I would say
Where
any observation is going to require us to use our senses and our cognition to understand that sensory input.
if you're an idealist, I think that a transcendental idealist, that is, I think that you would say that they are happening simultaneously, where it's like there are ideas outside in the world, and
Hmm.
once we make contact with those ideas, the ideas in our brain, kind of,
Yeah, I mean they're
you
empirical.
know,
If it's transcendental idealism, then the phenomena is empirical,
right, and so
regardless of what we think about the noumena.
yeah,
I would say the noumena is a bit different than thinking about objective reality in science, because you're talking about systems that have objects and a substance in which these objects have properties. That is not necessarily so in philosophy, because you don't necessarily have to argue from systems.
it doesn't even need to be Kant, though. It could be Plato, it could be Leibniz. Leibniz
Yeah.
thought that the most fundamental units of the universe were immaterial and, in a sense, ideas, right?
Hmm.
I'm referring to monads here, of course. And so, a world like that, I can see the simultaneousness of it.
The simultaneity, I think, is the word, but I could
Simultaneity,
be
yeah.
wrong.
I was going to say that, but I was afraid to
I
botch.
could be wrong, but I'll
Yeah,
fucking say it. Simultaneity. I
nice.
think that's right. It sounds right, but I
If
could
it's
be
not,
like,
then we'll create it and we can copyright it.
we'll correct it sometime. Who cares? Fuck it. Um, so let's just say, therefore, observations are affected by one's underlying understanding of the way in which the world functions, our heuristics, our cognitive biases, our perception, what we deemed worthy of consideration in that instance. It can be all. It can argue that all observation is theory laden. And that's what Thomas Kuhn is gonna say, that you can't separate the presuppositions from the induction. So, well, we could there's obviously way more to go, because we can cover. We're going to cover historical methods next time, and we're going to cover. I'm going to cut. We might cover the purpose of science real quick, because it's just a real quick section, and it's quite obvious. But we will next time get into the history, the pre-modern, logical positivism, Thomas Kuhn, and then we will get into current approaches like naturalism, metaphysical naturalism's axiomatic assumptions. The presuppositions, things we've talked about before, things we talked about last time, our first principles and presuppositions based on those. Go back and watch that episode; it's awesome. We had a good time. Then we can talk about coherentism a bit, if we're an idealist or an anti-realist. Coherence theory of truth may be a more appealing methodology if you're a part of those kinds of philosophical inquiry lines. Let's see what else we're going to cover. We're going to go look at the anything goes methodology. We're going to talk about the sociology of scientific knowledge, and then we're going to talk about what's I have messed up. I'm lost. We're going to talk about arguments against realism and anti-realism. So I guess we can just quickly cover realism. Well, no, we'll save that. Because it's more of a meta problem. So we'll save that for next time. Um, yeah, let's save that for next time. So Perry,
Yo,
what? Oh damn, I had it on the tip of my tongue. Is
you're gonna say purpose?
where do you fall on the justification in science? Do you think? I don't know how to word this question properly. So, do, do you think that we can justify science through the normal means of like epistemological justification?
Well, I think that philosophy is an umbrella under most, if not all, knowledge. And when we're talking about the scientific method, we are talking about epistemology, it seems to me. So there's going to be some custom theory of epistemology or criterion of truth,
Mm-hmm.
a little bit of pragmatism in there, a lot of bit of empiricism, a little bit of what's the idealist rationale of coherence.
Coherence.
There's right. So it's going to be so yeah, it does overlap, if that was the question, with
Yeah, I mean that answers it pretty
yeah.
well. I mean, it's just all of what we've been talking about is how we justify, what is a good example, what is a good reason to believe. It's like the problem of induction. What's a good example to trust our induction? Well, we can't. Tomorrow might be different. Tomorrow, the laws of physics could reverse themselves, and we could all die. I mean, induction can only get us so far.
Well, what's a good reason is that it helps you live another day if you presuppose that living is better than dying. It seems as though a lot of that gives us practical application into surviving and thriving and getting, and achieving our desires. Um, so that would be a reason if you
Well, I
presuppose
guess
that.
I guess regardless, and you're right. I mean, I guess regardless, the justifications of science today are leading us to better technology. It's obvious. This is the evidence of why science is important, is because we can predict the future events, and we can create technology to survive and thrive better.
Medicine.
Yeah, medicine, everything, all of that. I mean, the single most useful tool we've ever had as humankind, that methodology and philosophical skepticism. But those two ideologies. Um, but like, if you're justifying science, I would say it's like a pounded into everybody's heads. If your justifications in epistemology are the same as your justifications for the scientific method, and you interlock those two together, you're going to be getting closer to the truth, which is what a justified true belief is in epistemology. You're going to be closer to that truth than you would be if you just used arbitrary justifications or circular justifications or some other logical fallacy that might lead you to other forms of ideas of justification that aren't explainable or fringe, you know. Um, Next time we're going to talk about a lot about scientific realism and anti-realism. I can give you a quick understanding. Realism means that there is a mind-dependent world out there, that there is objects in reality, and the anti-real part is a little bit more philosophical. It's saying that science is not that science is mind dependent. All of what science has learned and all of our models and theories about the scientific laws and the descriptions of nature are all socially constructed or are all just useful instruments, but they're not actually describing reality. That's mind dependence. Now, the mind independent people, the realists, are going to say yes, depending on the degree of realist they are, they're going to say yes, these scientific theories and models are accurately representing reality in some way. So I fluctuate always, the fence sitter. I fluctuate between realism and anti-realism. If I'm doing science and I'm in a lab and I'm required to do the scientific method, I'm going to act as though I'm a scientific realist. Maybe on the middle part of it, where it's like constructive uh, cons- uh, constructive realism or something like that, we can go over that. But there's many different positions in the real, and there's many positions in the anti-real. And there's metaphysical positions that underlie those, and we'll go over those next time. We'll get a little bit deeper into it. There's also, I wish I could post an image, because me and Perry have this really cool philosophy of science image that explains on a graph where people would fall. We might be able to get that up there next time, but right now it's not a huge worry. Well, let's say, guys, it's been an hour and 20 minutes ish, and I think I've probably tortured everybody enough, which is the whole point of this series. So we will dive deeper into scientific real. We will go deeper into these things, and I will try to hurry it up a little bit more next time. I just enjoy this dialectic with Perry. It's like what I love to do, and he's my ultimate partner for this. Um, so, Perry, did you have anything to add before we look and see if there's other callers, or if there's any questions that we need to answer, or anything
Yeah, I
else?
was looking at both chats. Doesn't look like we got anyone in a caller queue or anything.
Okay.
But
Well,
no, I'm I enjoy doing this. We've been doing it for a while.
we're going to continue to do it, I hope.
Yeah, yep, definitely. So
Well, everybody, it's been a rather short episode. Because I don't want to overload people with too much information. I want that to sink in, what we've already talked about. And we've really gone over a lot of stuff that, if I continue reading, we'll eventually get to what we've been talking about anyway. We go off on so many tangents, but I hope they were all relevant, and I hope you stuck with us and got through all the difficulties. If there's any questions, you can always, I guess you can comment on these videos, ask questions. We'll come back and see if we can try to answer them. And if we can't, we'll say, I don't know, and we'll try to figure it out together. But I'm going to go ahead and say, please subscribe to the Pangburn YouTube. The Discord link is in the top right of the Pangburn YouTube. Please subscribe on here to the Pangburn Universe on Rumble. And also, please, well, on any platform, Instagram, Twitter, Facebook, all the places that the Pangburn Universe exemplifies itself. Um, and please keep coming to my shows, guys. I love talking about this stuff, and I want to interact with you more. I want you to be able to call in at the end of these episodes and ask the questions that are important, because I want to see if I can answer them to the satisfaction of people calling in. I want to be as salient, succinct, and specific as I can, and I hope that of other people as well, that we can come to better understand what is most likely true. Um, I think that's all, guys. I think we're going to go ahead and play the outro. And I love you guys, and I love you for coming. And have a good night.
we'll see you next week. Peace.
We need to be able to have conversations without feeling like we're going to say something that gets us thrown in jail because people happen to be offended.